morning, students. So today we are going to study the tracing of polar curves. How polar curves are given? They are given in the form of equations, and equations are in the form of r and theta. So equations of polar curves, they contains r and theta. We can write it as r equal to f of theta. Now for polar curves, some basic things we need to study first. The basic thing is, the first definition, it is pole. So what is pole? Pole is a point which is called as origin in Cartesian system. So pole is a point from which all distances are measured. So pole, it is a point from which all distances are measured. From which all distances are measured. Distances are measured. So we call it as origin in Cartesian system. So from origin we measure the distance on maybe x-axis, on maybe y-axis. Likewise, in polar system, pole, it is a fixed point from which we measure all distances. The second definition which we are going to study, it is initial line. The second definition is initial line. So what is initial line? Initial line, it is a line from which all angles are measured. So in Cartesian system, we used to consider positive x-axis from which we used to measure the angles. So initial line is nothing but this line. From this line we measure the angle. If suppose I want the angle theta equal to 90 degree, then I will start measuring the angle from this line, and I will aim up to 90 degree. Okay. So initial line, it is a line from which all angles are measured. And third definition which we require, it is equation of line. Equation of line. How we represent any line in polar system? The line in polar system can be represented as theta is equal to alpha. So alpha is constant. If I write theta is equal to pi by 2, it means this is the line. Actually it is an angle, theta is equal to pi by 2, but this is the line which is at 90 degree from initial line. So from initial line, 90 degree, it means this line. So equation of this line is theta is equal to pi by 2. So any equation in polar system can be represented as theta is equal to alpha. Okay. So after studying these three definitions, that is pole, initial line and equation of line, now we will see that the procedure to trace polar curves. So like Cartesian curves, here also there are 4 points. In Cartesian we used to find symmetry, then origin, points other than origin, asymptotes, the region of absence, and then shape of the curve. So in polar curve also, the first point we will study is symmetry. The second point, it is pole, which we call it as origin in Cartesian. The third point, it is table of values. In Cartesian we used to call it as points other than origin. And then fourth point, it is tangents at some values of theta, and fifth point, it is trace of the curve. So we will see first point, it is symmetry. How we check the symmetry of the curve? If equation is given in polar form. If given equation remains unchanged by replacing theta by minus theta, basically the equation in polar system is given in terms of r and theta. So if I replace theta theta by minus theta and equation remains as it is, then curve is symmetric about initial line. So initial line, it is nothing but positive x-axis. Okay. The second point is, if equation remains unchanged by replacing r by minus r. If equation remains unchanged by replacing r by minus r, then curve is symmetric about pole. For example, if suppose r square is equal to a square sine 2 theta. Suppose this is the equation. If I replace r by minus r in this equation, equation will remain as it is. So this curve is symmetric about pole. Third point, if equation of curve remains unchanged by replacing theta by minus theta and r by minus r simultaneously. If theta by minus theta and r by minus r simultaneously, and if equation remains as it is, then curve is symmetric about theta is equal to pi by 2. For example, if suppose I take r square is equal to a square cos 2 theta, then if I replace r by minus r, this r square will remain as it is. If I replace theta by minus theta, then cos of minus angle is cos of plus angle. So this cos 2 theta will remain as it is, and therefore this equation remains as it is after replacement of these two, and therefore the curve is symmetric about the line theta is equal to pi by 2. But there are some curves. For example, if I take r is equal to a into bracket 1 plus sine theta. So this curve is symmetric about the line theta is equal to pi by 2. But if I replace r by minus r and theta by minus theta simultaneously, then this equation will change. Then for such equation, we will try one more. Replace theta by pi minus theta. So if I replace here theta by the angle pi minus theta, then sine of pi minus theta is adding sine theta. So equation will remain as it is. So after replacement of this, if equation remains as it is, then also curve is symmetric about theta is equal to pi by 2. Now the last point in symmetry, that if we replace theta by pi by 2 minus theta in the given equation, if equation remains as it is after this replacement, then curve is symmetric about the line theta is equal to pi by 2. Okay. Now the second point to trace polar curve is pole, which we call it as origin in Cartesian system. How we get pole? For getting pole, we should put value of r 0. Value of r 0 means what? This distance, it is 0. It means point is at pole. So for getting pole, put r is equal to 0 and then get the value of theta. For example, if suppose equation of curve is r is equal to a into 1 plus cos theta, then when we substitute r0, this implies a into 1 plus cos theta is equal to 0, and this is nothing but cos theta is equal to minus 1, implies theta is equal to 1. So by putting r0, get the value of theta, and this value of theta represents equation of tangent at pole. Okay. So first substitute value of r is 0. After putting r0, get the value of theta, and this particular value of theta is called tangent at pole. Okay. Now the third point is table of values. So here we are going to prepare one table containing some values of theta, and then accordingly we calculate values of r. But the thing is, how to decide these values of theta? Whether to take it from 0 to pi by 2 or 0 to pi or pi by 2 to pi. So it depends upon the term it contains in the equation. If equation contains cos theta, how to decide the range of theta? If equation contains cos theta, then cos theta have maximum value. Cos theta have maximum value 1 at theta is equal to 0 because cos 0 is 1, and minimum value it is minus 1 at theta is equal to pi. So if equation contains cos theta, then take the range of theta from 0 to pi. Again, it is not compulsory that we should take only this range. You can take 0 to 2 pi also. But the minimum range which is required to trace the curve is 0 to pi. So if range is from 0 to pi, then values of theta will be 0, maybe pi by 4, pi by 3, pi by 2, 3 pi by 4, and then pi. Okay? And accordingly calculate values of r. If equation contains sin theta, then sin theta have maximum value 1 at theta is equal to pi by 2 and minimum value minus 1 at theta is equal to 3 pi by 2. It means if equation contains sin theta, the range of theta will be from pi by 2 to 3 pi by 2. So if range is from pi by 2, you can select the values of theta as pi by 2, 3 pi by 4, then pi, and then 5 pi by 4, and then 3 pi by 2. If equation contains cos 2 theta, cos 2 theta have a maximum value 1 when 2 theta is 0. Try to understand. If I substitute value of 2 theta is 0, then cos 0 is 1. And it implies theta is 0. And cos 2 theta have minimum value minus 1 at 2 theta is equal to pi. Then what is the range of theta? Range of theta, it is 0 to pi by 2. Because when I transfer this 2 on this side, theta will be pi by 2. Then if range is from theta is equal to 0 to theta is equal to pi by 2, you can select theta 0, pi by 4, pi by 3, pi by 2. Okay. Now, if equation contains sin 2 theta, then sin 2 theta have maximum value 1 when 2 theta is equal to pi by 2 and minimum value minus 1 when 2 theta is 3 pi by 2. Now, what is the range of theta? Range of theta, it is from pi by 4 to 3 pi by 2. So if range is from pi by 4 to 3 pi by 4, you can select the values of theta as pi by 4, then pi by 3, pi by 2, 3 pi by 4, and then pi. Okay. So likewise, we can select the range of theta, and accordingly we should calculate the values of r. Now the next point, it is tangents at theta. Okay. The next point is tangent at theta. Now how we calculate tangents at these points of intersections? At some values of theta, we are going to calculate the tangent. So for that, first of all, understand this diagram. This is the curve. Let P r comma theta be the point on the curve. At this point, this line is tangent. This tangent makes an angle psi with initial line. This is the radius vector. We call it as OP. This point is O, this point is P. So the radius vector is OP. It is represented as R because this point is a distance R. The angle made by radius vector with initial line is theta. Now psi is exterior angle and theta and phi are interior angles, and therefore we can write psi is equal to theta plus phi. How we calculate phi? We calculate phi by using tan phi is equal to r d theta by dl. After getting phi, substitute this phi here and substitute the value of theta at which we have to calculate the tangent. Then we will get the value of psi. So in this way, we calculate the tangents at the points of intersections. Okay. Now, after considering all these points, that is first point symmetry, second point it is pole, third it is a table of values in which we are going to calculate the tangents, and after getting tangents, by considering these all points, we have to trace the curve, and that comes under shape of the curve. Okay, is it understood?